You spent real money on the setup: a prosumer grinder, single-origin beans, and a machine with pressure profiling. But the coffee is still just fine. 9 out of 10 molecules in your espresso are water. In a filter brew, that number climbs to 98.5%. The beans you obsessed over are the smallest part of the physical beverage. Most people assume that pure distilled water is the ideal blank canvas, that removing every variable allows the coffee to shine through without interference. But distilled water is actually a terrible solvent. Flavor extraction isn't passive. It's a chemical process driven by ion exchange. Without specific minerals, the water lacks the tools to pull flavor compounds out of the bean, leaving the cup tasting sharp, sour, and hollow. Water is the active chemical solvent that decides whether the flavors you paid for actually reach the cup. Extraction requires a specific profile of dissolved minerals to act as a flavor-grabbing catalyst. These ions bind to the organic acids that define specialty coffee. But when those minerals are subjected to the high heat and pressure inside an espresso boiler, they precipitate out of the liquid. They fuse to metal surfaces as a rock-like buildup. This creates a direct threat to hardware. These intricate metal boilers and narrow water passages are highly susceptible to mineral scaling. The financial stakes are high. Over 5 years, the cost of descaling, repairs, and lost revenue from machine downtime in a commercial or high-end home setup can exceed $18,000. This is the machine versus taste paradox. Optimizing water for flavor risks destroying the boiler, while stripping minerals to protect the gear leaves the coffee tasting lifeless. There is no universal best water, because your treatment strategy is dictated by the specific hardware you brew with. 3 ions determine what you taste. First is magnesium. Its high charge density makes it a flavor grabber that binds to the fruity acids defining origin character. Then there's calcium, the bodybuilder. It extracts heavier compounds, contributing to creamy mouthfeel. But calcium is also the primary driver of lime scale, the reason your machine fails. The final variable is bicarbonate, or alkalinity. This acts as an acid buffer, neutralizing the natural acids in the coffee on contact. When bicarbonate crosses 70 parts per million, it becomes a killer of specialty flavor. It neutralizes the bright citrus and stone fruit notes before they reach your palate. The result is a cup that tastes dull, chalky, and earthy, regardless of the quality of the roast. Mastering water means treating these 3 ions as a balancing act. Simply checking your total dissolved solids isn't enough, because that single number can't tell you if you're measuring flavor-grabbing magnesium or acid-erasing bicarbonate. Municipal tap water is treated for safety and infrastructure protection, not extraction. In London, geology produces extremely hard water. Alkalinity levels are regularly 5 times the specialty coffee target, effectively neutralizing any acidity in a light roast. In contrast, cities like Melbourne have naturally soft water. It protects machines but produces hollow, under-extracted cups unless you add minerals back in. You have to audit your baseline. A $10 aquarium drop test kit will show you your exact general hardness and carbonate hardness levels. Knowing this baseline is the only way to avoid buying a filtration system that is wrong for your specific geography. Intervention A is the blank slate. Start with distilled or RO water and add lab-formulated mineral drops. This gives you the highest possible flavor ceiling, but requires the tedious workflow of mixing every gallon of brew water by hand. Intervention B is the ion exchange. This is a plumbed inline filter, designed specifically for espresso setups. These filters use a chemistry hack. They swap out scale-causing calcium for flavor-enhancing magnesium as the water passes through. However, these systems cannot fix water with severely high natural alkalinity. For extreme water environments, there is Intervention C, reverse osmosis. RO provides total machine protection, but it has a high upfront cost and wastes 3 to 5 liters of water for every 1 liter it produces. Every intervention introduces a new form of friction. The right choice depends on your specific geography and your tolerance for workflow. The first split in our decision tree depends on your gear. Do you have a boiler to protect? For AeroPress or V60 users, there is no boiler. Your path leads directly to the distilled plus mineral drops method. Your only goal is maximizing flavor clarity. If you have an espresso machine and your test kit reveals soft to medium tap water, you should route towards an ion exchange filter. This protects your machine's warranty and avoids the environmental waste of RO while still providing a sweet, balanced extraction. If you have a high-end machine and live in an area with incredibly hard, scaling tap water, a reverse osmosis system is the necessary choice. This logic tree maps your hardware risk against your tap water baseline, providing the framework to navigate the trade-offs of the machine versus taste paradox. Ignoring the chemical makeup of your water negates the effort you spend sourcing beans and calibrating your grinder. Managing your water profile is a foundational requirement for anyone serious about specialty coffee. Audit your tap water baseline this week. Test for hardness and alkalinity, then choose the intervention that matches your hardware. Treating the solvent with as much respect as the bean serves as an insurance policy, ensuring a $2,000 machine isn't ruined by 2 cents of municipal tap water.